Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 18 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of classes, and in this class we are using the Sunfounder Raphael Raspberry Pi kit. Most of you guys probably already have your kit. If you don't, look down in the description. There is a link over to Amazon where you can pick up this same kit that I am using. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to teach you today is how to incorporate a joystick into your Raspberry Pi projects. Now, luckily, the Sunfounder kit has a joystick, and so let's go ahead and get that out. What I will do is I will switch out of your way a little bit and give you an overhead view. And if you'll go ahead and open your kit up, and then if you will look on the second level, so you take the tray out, you will find one of these Mylar bags with a joystick in it. You can imagine I've already taken my joystick out of the bag, but you'll need to go ahead and find your joystick, and then what you'll need is 5 of these female to male wires. So go ahead and get 5 wires. If you want to use the same colors that I am using black, red, orange, white, and yellow, just because I can. So let's go ahead and let's put our kit back away neatly, keep everything in its proper order, and then let's sort of look here at what we are going to build. Now, a little bit about what a joystick is, and this, if you're following along methodically in this class, it'll make a lot of sense. What the joystick is it is 2 potentiometers and a push button. Okay, the last few lessons we have learned how to read values from a potentiometer. In fact, last week we had 3 potentiometers and we were reading the values from the potentiometers. What you have to do is you have to think of the joystick as 2 potentiometers and a push button switch. And so the way you control the potentiometers is basically, instead of turning a knob, it is, and let me move this, always I'm referenced with the pins to the left, that when you move left and right, you are changing the value of the X potentiometer, and when you go up and down, you are changing the value of the Y potentiometer. On the X value, this is the minimum value, this is the maximum value, and Y, this is the minimum value, and this is the maximum value. And then when you press the button, if you press down on the controller, you'll feel a distinct click. That is the button switch. And so that's how this thing works. Well, hopefully you guys did not tear down your circuit from lesson number 17, because remember that we had the ADC0834 hooked up to the breakout board, hooked up to the Raspberry Pi, and this ADC0834 is necessary if we want to do analog reads, the type of thing that you've got to have if you're going to try to read from potentiometers. So what I did from last week's lesson, I basically have pulled out the RGB LED, I pulled out the 3 resistors, and I have pulled out the 3 potentiometers, and so I just end up with the ADC0834 connected up. Now, if you need to redo this from scratch, I've got the schematic here, and you can just maybe freeze frame this video and you can grab the schematic and then you can go in and hook it up. I'm not going to step you through step by step hooking up this ADC0834. If you're not comfortable with that, go back and I kind of take you through it step by step in the last lesson. But what I'm going to be doing today is I'm just going to be adding the joystick. All right, so let's go back and let me show you how to hook up the joystick. I think you could do it better just by watching me do it live. And so again, when I have the pins pointed towards me, the leftmost pin is ground. And so I have a black wire hooked up to that. And the way my board is configured, my lowest row down here is my ground. And so I will put that in ground. And then the next pin to the right, pin number 2 on the joystick, is the 5-volt connector. For me, that is the second to the bottom row. And so I will hook that up to 5 volts. And now the next pin over, pin 3, the next pin 3 over, pin 3 on my joystick is my orange wire, and that is the X controller. I am going to connect that to channel 0 of the ADC0834, and that is pin 3. So we come over 1, 2, 3. That is channel 0. And now I'm going to hook the Y value of my joystick, to channel 1 on the ADC0834, and that is pin 4. 1, 2, 3, 4, and that will be channel 1. All right, now the final thing is this last wire, my yellow wire. That is the push button switch, and so I'm going to hook that to my breakout board to GPIO pin 21, which on the top will be the rightmost pin, like that. Okay, and so this upper right, it's labeled here GPIO 21, and so you should be able to hook that up. Now I should be set up to read the X and the Y value from the joystick and be able to detect a click. All right, but we will need to program that up. So I'm going to switch over to a code view, and I think that you should be able to see it pretty well here. Yeah, that looks like a view that you should be able to see. Coding this thing up should be pretty straightforward. You should be able to do it on your own because it's very, very similar to what we did in lesson 17 and some of the earlier lessons. But we'll run through it here really quickly. What you'll need to do is come down and open up your IDE. We are using Thony, so we will open that up. And then, let's see here. Okay, so we're here with an Untitled. I always like to start by saving before I start programming. So I'm going to come up here and I'm going to say save, and then it should pop up. I'm going to save this as joystick.py, and the .py is kind of important. And so now we're ready to start coding. Okay, if we're going to interact with the GPIO pins, the first thing that we're going to need to do is we are going to need to import the GPIO library. So we're going to say import, and then that is uppercase RP, lowercase I dot GPIO, and then import that as GPIO. You can import it as whatever you want, but whatever you import it as, that is the name you use when you want to address the library or access the library. We will import it as GPIO. Now we need to also import the ADC0834 library. Now this library does not come with the Raspberry Pi, but I showed you in lesson number 15 how to install this library. If you don't have the library, run back to lesson number 15 and I'll show you how to install it. It's on my Top Tech Boy, and it's on lesson number 15 on this playlist on YouTube. We're going to want to put delays in, so we're going to also import time. Now we need to get things set up. Now remember that when I was plugging this joystick in over here, when I was plugging this joystick in, I plugged it into GPIO 21 on the breakout board. But remember, the breakout board is not using the physical pin numbering system, it's using the BCM numbering system. And so I need to be sure and tell my program that so they know, so the program knows how I am referencing the pins. And so let me come back to our code view. So I need to go ahead and set that up. And so I will do a GPIO dot setup set up, and then set up. And then what am I going to do? I am going to tell it that it is GPIO.BCM. So I'm using the BCM numbering system. So the Raspberry Pi should know that at this point. Now I also need to start my ADC0834 analog to digital converter, and that's very easy. I just reference ADC0834 dot, and then I just do a setup, no parameters, like that. That should be good to go. Excuse me, I've got my 3D printer running here, and it is putting out PLA fumes, and they are making me a little scratchy in the throat. So sorry for the coughing, but I am running my 3D printer over there. Okay, so we've got the ADC0834 set up and ready to go. We need to go ahead and define our button pin. Remember, that was pin 21, so we will say button pin is equal to 21, and that is BCM pin 21. And now we need to go ahead and set up our pull-up resistor. So we're going to do GPIO.setup. We don't want to do an external pull-up resistor. We want to use the built-in pull-up resistor. So we're going to set it up. And where are we going to set up that pull-up resistor? On button pin. And I need to make sure that I use exactly the same case. So button pin, button pin. And now this is a little confusing, but this is just the way we do it. We've got to say GPIO all uppercase .in. And so I'm going to make that an input pin, and then I'm going to say pull all lowercase, up all lowercase, down all lowercase. Okay, and that's going to be equal to GPIO uppercase .pull up down underscore up. And that is just a long, complicated way of turning on the internal pull-up resistor on pin 21. Pay attention to case. You've got to get the case exactly right. All right. Now what I'm going to do is I am going to go ahead, and since we always want to clean up our program when we exit out, I'm going to set up a try and an accept with a keyboard escape, and that way I can have a little clause of code that I run when I exit the program to always clean up those pins. And so I'm going to say try, and I'm going to try as long as I don't have a keyboard interrupt, and then when I do have a keyboard interrupt, I am going to come down to the accept. Okay, and then what do I want to do in the accept? I want to come over and I want to do a GPIO dot clean up like that, and then I want to make sure that this code that I know this code has executed. So I'm going to print so I can see that it got down here. GPIO good to go, like that. Okay, GPIO.good to go, close that out. And now I need to come back up and actually write the main part of my program inside the try. So it'll stay in the try until it sees the Control C, the keyboard interrupt, and then it'll jump down and it'll clean up the pins. Okay, so what do we want to do? We want to do a loop here so that we keep reading. So we're going to say while true, when is true, true, true is always true. So we're creating an infinite loop there. And now I want to read the analog value from the X of the joystick. And how do I do that? Well, that is done by doing the ADC0834 dot get result like that. And then the X value was hooked to which channel? It was hooked to channel 0, which is pin 3 on the ADC0834. Now I also want to analog val Y, and that is ADC0834 dot get result. And which channel was that hooked to? It was channel 1, which was pin 4 of the ADC0834. Now what do I want to do? I want to read the button. So I'm going to say button state is equal to GPIO. We just want to do a simple digital read, so we do an input, and we've already set up our pull-up resistor, and so we just do that, looking at button pin, being careful to get the case exactly like I did it before. Read X, read Y, read button state. Pretty simple. Now let's just print them out. So I'm going to say print, and then I'm going to say the X value like that. Okay, and then I will print analog val X. Does that look good? I hope so. And then I'm going to print Y value, and that will then be analog val Y like that. And then I'm going to print button. Looks like I need to get out of I think I can. Let's see if I can pull this up. Yeah, I can pull that. Pull that up and fix it by getting further out of your way. All right. I know you guys hate it when my head goes over the code. Okay, so button, and then close that, and comma, that is going to be button state. And then close the parenthesis. All right, I print those things. Now I want to do a little bit of a delay, so I'll just say time.sleep, and let's put in a 0.2 of a second delay, meaning we'll get 5 readings a second, and that should be pretty good. Okay, so let's think about it. We imported our libraries. We set up our ADC0834 chip. We set up the GPIO pins, telling them that it's the BCM numbering system. We activated our pull-up resistor, and we activated it as a pull-up resistor. And then we read channel 0, we read channel 1, we read the button, and then we print them all out. Could it really be? Could it really be that easy? I hope it is that easy, but we're going to run this thing and see what happens. Also, I think when I run it, I should show you the combo view where you can see the code, see what's going on with the code, and let's see if we can move this joystick over here where you can see what is going on with the joystick. Okay, so now what do we expect? My little wire is not all the way on there, so I want to get that kind of straightened up. Make sure I get these in there good. All right, now what do I expect? Well, when it's in the neutral position, it is kind of like neither left nor right, and so we would expect it about halfway between 0 and 255 on X, which would be about 126, somewhere around there. And then what we would expect is on Y, it would be halfway between 0 and 255, or about 126 or 127, somewhere around there. And then we would expect, because the button isn't pressed, we would expect the button state to be 1. So we would expect something like 127, 127, and 1 when we ran this program. So we're going to see what happens. Come over here. Let's make sure that we save this thing. And then what I will need you to do is I will need you to hold your breath. Direction. What is that? What did I do in line 4? Okay, man, that looks so right. What did I do in module? In direction. What did I do? GPIO dot set up. Oh, not set up, man, not set up, set mode. Set mode up here. Okay. I'm not doing a setup, I'm doing a set mode. And the mode that I'm going to is the BCM mode. Okay, rookie mistake. You guys realize that it's been like months since I programmed in the Raspberry Pi. I'd put together all of those lessons and then I was releasing them once a week, and then I went away and worked on the Fusion 360 lesson. So I'm a tad bit less rusty on the Raspberry Pi, but we will power on through. All right, we'll try it again, and there is one other line of code that I want to put in here. I just always like to put a little bit of a delay between my reads just to make sure that we're not messing with the timing on the chip. And so I'm going to go ahead and just put a time.sleep of 0.1, just a little brief pause between the two reads. I think just a good practice to do that. And so this time I will need everyone to hold their breath. And boom, look at that. Okay, so we are reading 116 on the X. That's about roughly in the middle of 0 and 255. We're reading 114 on the Y, and the button is up, and we are reading 1. And so let's come in here. And now what I'm going to be doing is I'm going to be moving to the left, and we're going to expect that 114 to go down towards 0. And so I'm going to be moving to the left, and we can see that we can get all the way down to about 5 when we go to the left. And then as I start coming back to the neutral position, it starts coming back up and it comes to 114. Now when I go to the right, I can come all the way over to about 220, and then I let it go. Now let's look at our Y range. On Y, I can come up and I can go down to about 10, and then when I come over here and pull it back, I can go to about 215. And so one thing you can see is, just as I'm playing with this potentiometer that I have is not going the full range. I'm not able to go from 0 to 255. It has a little bit of a limited range. And what you're going to see is every joystick works a little bit differently. Ideally, when I'm fully to the left, I would be at 0. When I'm fully to the right, I would be at 255. When I'm fully up, I would be at 0 on the Y, and when I'm fully down, I would be at 255 on the right on the Y. You can see that this one is going from about 5 to 220, which is a little bit of a limited range. A better, more expensive, more precise joystick would more perfectly match that parameter space. Now, the other thing you care about at what range of motion you get the full variation in values from the joystick. So I'm going to be coming to the left, and as I am moving to the left, you can see that I start going from the 116. I start moving down to 80, 35, and when I'm about a third of the way over, I have already gotten my full range of values. And so it's not from here all the way over that you get changes. It's from here to about a third of the way over. Now let's see, coming back to the right, I am seeing a very similar thing. Maybe at about halfway, I get pegged out on my numbers, and here it's about the same thing. Okay, so what that's saying is around the outside ranges of motion, you're not really getting any change in the value of the joystick, and the real action is happening kind of in the center, so it's going to be pretty sensitive on its motion. Okay, what I will say is we've programmed it right, we've hooked it up right. This particular joystick you would probably find frustrating if you were trying to use it in gameplay, because the active, the live region is just a little range of motion around the inside. What this joystick does allow you to do, it allows you to kind of learn how to program it and learn how to connect it. If you were trying to do precision robotic control, you would probably want a better joystick than this. But we will be incorporating this joystick into projects in the future, and you now know how to hook it up. Okay, what one other thing do we need to check? We've checked X values, we've checked Y values. What else do we need to check? We need to check the button push. And so without the button pushed, you are at button state 1, which we expect with a pull-up resistor, and when I press it, boom, get a 0. And so the button push function is working, the X value is working, the Y value is working, and so we've got this thing hooked up. And what we could do now is we could use this joystick in a project. All right, guys, let me switch back over here to the Riverview, and let me say I hope you guys are having as much fun taking these lessons as I am making the lessons. If you enjoy the video, be sure to give us a thumbs up. Leave a comment down below, because comments and thumbs up help us with the old YouTube juice, and the more people that comment, the more people that give a thumbs up, the more people this video will be showed to. And that's important, because the world needs more people programming and building circuits and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.